Yeah, we're ready. Okay, welcome to weekend session number 2 of Object-Oriented Design in Java. And somebody just told me that we didn't cover inheritance yet. We didn't cover inheritance? I thought we did. Well, we can review inheritance, actually. In fact, we'll take a few minutes and do that. For brand new people, which I have 2 of here, or one I know needs this information. Write this URL down, www.bhacker.com. Actually, you don't have to do the /ITU. In fact, I'll put it on the board for you. It is, oops, well, that's good. They gave me a pen, and the pen doesn't work. bhacker.com. That's where you're going to find all of the course materials, video lectures, recorded lectures, PowerPoints, assignments, homeworks, everything is at that location. And the weekday class is running simultaneous with it. You attended it last year, so okay. No, that's fine, but you're familiar with it. If you go into the weekday class section, you'll see all of the materials. The weekend is kind of empty. You have to actually go into the weekday section in order to find it. You go under the Object-Oriented Design in Java, and you'll see up here course materials. Click on course materials. It'll take you to assignments. There's 4 assignments, actually 5 assignments, I'm sorry, for this course. And we have some recorded, these are the weekday lectures. They're not bad because they're in smaller settings. Each one of them is about an hour and a half. You know, maybe one of them I think is like 2 hours. But they're between an hour and a half and 2 hours. And I tried to put down all of the concepts. And so I think we should have gone through. In fact, actually, I can probably figure out by looking at the video recordings. And if you missed last interactive session, hello. Weekend class in here has the lectures, so now I can find out what we went over. Actually, I didn't put it on here, so maybe that tells me in the future it's not a bad idea to put that on there. So I didn't put on what we covered in each one of them, but I believe we probably went through about lecture 4-ish, which would have brought us. But I'm going to talk about inheritance today as well. So, and you're putting together the roster sheet. Yeah. So you haven't missed anything yet. The roster's coming around here. And what else did you miss the last time? Just to give a little summary of what we did last time, we went through the first part of the course, actually, up until the midterm. And I'm going to talk about the midterm today. It's a take-home midterm. And I'm also going to talk about the CSLO assignment. And I'm going to talk about all 5. So what we're going to do today is cover all 5 of the homework assignments and get you ready so that you can actually do all of the work to finish the class by your next class meeting, which is in a month from now. You might be wondering, 5 assignments, a midterm, a CSLO, all this stuff is due in 1 month. Not really. You actually have till the first week in May. So your course deadline for all of the assignments is the same as the weekday. So we have some odd scheduling. You know, we only meet 3 times. And as I mentioned before, I don't know if I specifically mentioned it, but you know, you have to attend at least 2 of the 3. So most people attended the first and will attend the last. So some of you guys are getting bonus attendance because you were here for the first and the second and the last. You do have to show up for the last interactive session. You have to take the final exam in class. It's an attendance requirement. But the second session, I kind of expected a low turnout because a lot of students are going to opt to take that one off, especially if it's not necessarily required like the last one is. But yeah, you will have to show up in person for the last one. And the class will run on both days. And if you're interested in finding out what day that is, I've actually written it right here. So today is March 19th. The next interactive session is April 16th and 17th. And the TA is going to send out, he doesn't know this yet, but he's going to send out an email message we're going to take all the students in the course, and there's a lot more than that's showing up here. Divide you out into groups by the alphabetical order of your name or something. You'll dream up some scheme.
Yeah, I'll do it.
Put you in categories. Yeah. We'll send an email message out to everybody, so make sure that you have access to the ITU EMS so that you're on the mailing list, the email list. We'll send an email message out to the class with your group, whether it's on the 17th or the 16th. We need to do this soon because it's only a month away and students will have to order airline tickets.
Sure.
And the longer we wait,
Yeah.
the more expensive those tickets are going to be.
Yeah.
Okay. If you don't like your grouping, you can switch to another grouping. All you have to do is send me an email message or send the TA an email message and say, I want to meet on the 16th instead of the 17th, which I have a strange feeling a lot of students are actually going to try and do. Because if you're working, you're going to come out on a Saturday and you're going to fly home on a Sunday. So we will try to accommodate as many of you as possible on that on the 16th. We'll make the 16th grouping probably go from 9 o'clock in the morning until 6 or 7 at night. We'll try and get everybody in to accommodate, but we have to adjust the schedule as soon as we find out how many people are going to want that. Some of the local people might prefer the 17th. Well, number one, all the kinks in the system will be worked out, so we'll know what we're doing when you get here, and it'll be more organized, because we would have done it the prior day. And number two, the less chaotic, less hassle. You get in, you get out real quickly, you don't have to wait. And the 16th is going to be long waiting around because people are going to show up who weren't supposed to show up, and it's going to be more chaos. So if you want an easy kind of ride through it, the 17th would be my preference, actually, for taking it. But when the list comes out, depending upon where you are, we'll figure that out. Okay. I'm sorry?
Many students, so we have to.
Yeah, there's a lot of students, so we can't put everybody all on the same
And
day.
we have to figure out how the classrooms are there in the new building.
Yes.
It's going to happen in the new building.
Yeah, the exam, that's an excellent note. The exam will be in the new building. If you're not familiar, it's in downtown San Jose off of San Fernando. Yeah. Actually, it's a nice building. I just saw it.
You have the address on the website, though.
The address is on the website if you go to www.itu.edu. You'll see the address up here. So yeah, it's for those people who aren't local, it's about 20 minutes from here, maybe half hour from here. And in fact, it's probably cheaper to stay in San Jose than it is to get a hotel room. In fact, if you fly into San Jose Airport, just get a room around the airport. It's probably the cheapest, and then you can just stay like right there, and you probably could just taxi cab it for what, $10 or something like that.
It's just like if you get onto the train, it's just 2 stops. So.
Oh, if you get on the train, it's 2 stops. The light rail from here. Yeah, if you are from here.
San Jose Dirdon, you get down over there, and you take 22.
Okay, the 22 bus.
HP Pavilion, near HP Pavilion.
Okay, you know what? That may not be a bad idea to send out. Here's a little picture of the gymnasium. Actually, you'll love the building. It's huge, very big, very nice, actually. It'll be brand new. I mean, they're putting down new flooring, paint, everything. So it'll be like a brand new kind of facility, which is nice, actually. And then we'll make it all dirty in a couple months. So, and actually we have our WASC visit within, I think, about 2 weeks or so after we move in. So it'll still be new for the WASC people, which is good. So,
it's 355 West San Fernando, San Jose.
Oh, okay, here, I'll write that down, actually. 355?
Yeah.
I'll put that on my board here, too. 355 West San Fernando?
Yeah, West San Fernando.
San Fernando.
San Jose 95113.
95113. Okay. So we have the address written on the board for those of you who. I'm sorry. Did I spell that right?
Yeah.
Okay. Good. Very good. Otherwise, probably not a bad idea to send an email message out. When we send the message out about it, we'll just put the new address in there, so they know go to this address, don't go to this address. So I can kind of see that happening actually. So. All right. Let me go back real quick here to the website. The weekend classes, as we saw already, we have on here, and I've posted up here, it's the same. So if you see in here, midterm exam, CSLO essay, it's the same as in the weekday. So it doesn't matter where you pull it from. And for the brand new people, sorry to bore the people who already know this information, but for the new people, specifically, you can't send assignments via email. The assignments need to be uploaded into the ITU EMS. Which means if you're brand new, you're going to need an ITU EMS login. If you get the login, you'll actually get on the email list, and you'll know what's going on as well, hopefully, because you'll receive the correspondences between us. And so work on that. It's no big need. None of the assignments have been due yet. Everything is due on the very last day of the class, which is going to be the last day of the regular term, which is going to be the first week in May sometime. And we'll announce that as we get closer. I would say probably in the first part of April we'll announce that. The midterm exam is the only item that is due before the end of the term. That one is going to be due, believe it or not, on your interactive session weekend on April, 1 month from today, on April 17th or 18th. I think we set 18th as the deadline for the weekday class. It's the same deadline for the weekday as the weekend for that midterm. The reason why we want that is we want to make sure we have all the kinks worked out of the system. So we'd rather do it on the midterm than on all of your assignments, which means you're going to have to, hopefully it'll be the first time you've uploaded something into the class. If you get an error message, contact the TA. The TA can help you through it, or contact the IT, technical support, the help desk. The people that are on call that should be handling that for you as well. When you get the midterm in there, we're going to hopefully have it graded before the final exam, so you kind of have a little bit of an idea how you're doing in the course before we get there. And I'm going to go over the midterm. I'm also going to go over the CSLO essay in a few minutes as well. But I'm just kind of running through the administrative part of all of your announcements. And what I'm giving you is everything that you would have missed via email if you haven't been on the email list. So we've sent most of this information out, I believe, to people, yes?
Yes, like my enrollment is still pending.
Yeah, which means you haven't, that's why I'm repeating this. I'm doing it for you, because you haven't heard any of this. Yeah. Right.
I'm going to add you up.
Okay.
Yeah, if your enrollment is still pending and you're still not getting anything, the TA can actually get you expedite that for you, hopefully. Okay, so let's talk about, and it's kind of weird, but let's talk about the midterm, because this is really where we left off, and then I'm going to go through and talk about the CSLO essay, and then I'm going to go through and talk about the assignments. And while I'm doing that, I'm going to give you all of the lecture material without having to bore you with the PowerPoints. Because with a small group, I think we can be a little bit more flexible in terms of how we run this session. And it's a little bit more productive to actually see the code work, and rather than, you can watch the videos, because this is the advantage the weekend people have is that the weekday is going on at the same time. And so all of those lectures, all the PowerPoints, are being demoed for you in videos that are very easy to look at. They're in YouTube. Have you guys looked at the videos at all?
Yeah.
Okay, good. So you can go back all through every one of the 16 lectures and hear me talk about the lectures. You can also download the lectures and read them for yourself, which is why I don't want to bore you with that. So you guys are going to get everything you need to know to finish all the work in the class is what I'm focusing on today, is getting you so that you can turn in all the work and get everything done by the end of the term. So first order of business is this midterm. I'm going to make this a little bit bigger so you can see it. And this I presented as well. You'll see another interpretation of my spiel on it in the weekday video. In fact, this was just about last week or so. So we're taking it from where they cut off, hitting all the stuff that you missed between your first meeting and today, and then finishing up with everything else I'm going to give them, minus the PowerPoints, which I think most students find very boring to begin with. So you can skip through the videos and watch them, and you'll get the same benefit from it. All right. So what are you going to do here? This is the midterm. It is a take-home midterm. It is due again on the 18th of April, your last interactive session. This is the one you're going to be taking the final exam. Don't print it out and bring it to me. Post it to the ITU AMS. It's worth a total of 25 points, which is, good quarter of your grade. The assignments, believe it or not, that some students in the day session are freaking out on, they're only worth 5 points each. They're worth the same thing as the midterm. A lot more work, however, to do those 5 assignments than it is to do the midterm. A lot more work, actually. But the thing is, the assignments are actually good. I assume you've tried them because you're going, yeah, a lot more work. Yeah. Are you done with all of them?
I'm done.
Really? Wow. So now you'll see, you can compare what you did with what I'm going to show the class.
Yeah, even this is done.
You did this one too? Wow. Well, everybody else is not quite as fast, though. But yeah, no, so he can attest to it. This is easy compared to the programming assignments. But the programming assignments, you learned a lot, right? Hopefully. That's a loaded question. Were they learning experiences, the assignments? Kind of? The number 2 is the hardest, probably. The one with the person, employee, the inheritance / class static variables method.
You're talking about this?
No, the assignments.
Yeah, that one and the ping pong.
Ping pong was bad too. I know the last one. The second one and the last one was
that's
pretty
actually
bad.
too much for 5 points.
I know. I'm going to talk about them today. So, and well, unfortunately, you're probably the only one who's done most of them, because what I've done is actually yesterday I put it up on YouTube. Partial solutions to everyone except the last one. I haven't done the last one yet. Which, unfortunately for you, you did it on your own. The other students for their will actually have more of it given to them, which makes it. I took a look at it and went, well, this isn't really fair. This is a lot of work for 5 points. So, I should make it a little easier for them. So I put some videos up that actually explain most of the assignments for you. So.
In my opinion, each of the assignment should be like 10 points, not 5 points.
Yeah. The last one or all of them each?
The last one should be like 50 points.
Yeah. Yeah. No, you're right. But it is only 5 points. If you didn't turn in the last one and you did well on everything else, you could still get an A in the class. You get 95 points total. The reason why I made the points lightweight was because I know that they're going to be the most difficult part of the course, and I figured some students probably would do like half job on it. So you get like half points on it. So you can probably do like a half job on the second and the last one. Get 5 points total on it. Actually, probably end up getting 6 or 7 points. And hello, object-oriented design Java.
Yeah.
Yeah. And so you will end up kind of not suffering grade-wise. If you don't do any of them, it's 25%. So you'll end up with a 75 or a C+. So you actually have to do some of them. But the first one and the third one is pretty manageable. The fourth one is actually pretty good too. All right, let's go back to the midterm exam. And for those of you who just walked in, we're going over the midterm. I'm just starting it, actually. So you haven't missed anything yet. All right, so the midterm. We have 15 points in the first section. We have section number 2 has 4 points. Section number 3 has 6 points. And in the first section, actually, you felt the midterm was pretty, you said you already did it. It was fairly straightforward.
Yeah, there are a few questions kind of little confusing.
These down here?
You see the question number 15.
Number 15.
Do you have any deconstructor?
We don't.
Java.
We don't have a
Kind of
deconstructor.
question.
Do you have a deconstructor in Java?
No, we don't.
You don't?
But this is a why and why not.
Yeah, why
The
not?
answer was-
Why don't you have a deconstructor in Java?
Garbage collection.
Yeah, we have built-in garbage collection. We don't need one. That's all you needed to answer.
And also, like, garbage collection is not, we can't say like garbage collection is the deconstruction of Java. I mean, it's part of the job. It's not the total.
But it's different. It's a different feature.
Correct.
Yeah, it's a different
You
method.
cannot relate like the garbage collection is deconstructor. If you really quickly Google it, you can say like the deconstructor is garbage collection, but it's really not.
Correct.
It's not totally.
Correct, and you could have answered that way. So here's the way the questions work, and I'm glad you answered it actually, because I was going to talk about one of them, or now this is the one we're going to talk about, the 15th question here. How do you approach these? It says a sentence or two is sufficient. No source code examples. So you answer the questions in a few words. You probably, a sentence or two, if you can just note, if you heard what he just said, it's more than a sentence or two. You probably could have written like a paragraph or so, a couple paragraphs on that. Don't write a complete essay. So as an example, this last question down here, do we have a deconstructor in Java? Why or why not? I didn't say yes or no. So what I don't want you to do is, the reason why it says why or why not, because I know some students would say no. Yes. So these are not yes, no answered questions. These are why or why not. So to answer this particular question, well, obviously we've given you the answer. If you don't know this already, in fact, I think I may have even covered this. Hopefully, I believe I covered this information already in the first session. We have constructors, but we don't have deconstructors. If you don't know about C++ or C, you probably have never, C++, you have never even heard the word deconstructor probably, or copy constructor, or destructor, yeah. I like to call it deconstructor, because it's kind of like constructor, deconstructor. But some people call them destructors. I don't really care how it's pronounced, personally. But the deconstructor, according to the way I view it, is in C++, it removes any memory that's been allocated dynamically using pointers normally. But we don't have pointers in Java. So you could answer the question and say, well, why do we have a deconstructor in Java? Clearly, no. Why or why not? Well, if you said yes, why? Why or why not is basically, no. Why? Well, because, or why not? Because, and you don't have to say two of them, you just answer it why. So, because we don't have any dynamically allocated memory in Java. So there's nothing to deallocate. You could say that. Or you could say, as we pointed out, we have garbage collection. The garbage collection in Java does everything that a deconstructor would have done and replaces the concept. Or we can say, because it's not needed, because I don't know why it's not needed, but it's not needed because we don't have, it's not part of the language. Your level of detail is going to be on your background. It forces you, each one of the questions kind of has you think a little bit about the concepts, which is the purpose of the exam. It's an open book, open notes, open internet, but don't cut and paste off of the internet. It's easier if you just read the question and just answer it. You won't find the questions. I don't believe you're going to find the questions on the internet. Who knows? Number one, and I'm just going to briefly hit some of the ones, just as more examples here. Describe, and I've given it to you, a pie. That's in one of the lectures, actually. Describe the four main characteristics of object-oriented design. What's an instance? Define overloading. What's meant by overwriting versus overloading. There's a whole lecture on that as well. And then I give an example when you cannot overload a method in Java. That one probably is a little trickier because then you have to think, well, what do you mean can't? Oh yeah, I thought you can do it all the time. No, sometimes you can't, actually. So you have to find an example. And don't give me source code, just write it out. When there is a blah, 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 or a blah, 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 you can't overload it. Okay, good. Or something of that nature. So give an example when you cannot override, same kind of question. List the different access levels. And I purposely put access level in here to tell you, I want you to understand, because people will go on Google and go, access level. That's public, private, protected. I didn't want to say, list the different public, private, protected fields or method when you want to use. I want you to understand what the word access level means, essentially. Which is kind of like why we have some of the things in different fonts. In fact, hopefully you can see that on here. Some of the items here are in different fonts because I'm pointing out what it is I'm talking about, or what it is you're trying to learn. So super and this, polymorphism, constructors, abstraction. These other ones are fairly straightforward. Number 12 is interesting. Number 12 comes out of a lecture that I gave the weekday class about states, identity states and behaviors. It is the last lecture in the list. So if you go on the website and take a look, I think it's lecture 16 or something, which is, actually, wait a minute, I know which one it is. It is, I can tell you exactly which one it is. It is lecture 11. Well, I was way off. Lecture number 11 is not a bad lecture, actually, for you guys. It's loading right now. It goes over putting the pieces together in terms of the object-oriented concepts. And it goes through the concept of the object, the identities, the states, the behaviors. So just make a little mental note. That will help you answer that particular question. So question 12 works with lecture 11. Information hiding, inheritance, stuff like that. So the first part of this with the 15 questions is fairly straightforward, 1 point a question. The second part requires that you write Java source code. Don't write a complete program. You can get really carried away with this as well. When you need code snippets, pieces of code. For example, you want to know how to inherit one class from another. So you're going to put, base. Just don't put a ton of stuff in there.
So no need to explain?
No need to explain. All you have to do is provide me the source code. So show the Java source code how to inherit one class from another. You're going to use the word extends, with a base and an inherited class. And you're going to show me how to create an abstract class. We'll talk about that today. Interfaces. Talk about that as well. Subclasses. Overloading a constructor of a superclass. So small. Just think small is what I'm trying to say on that. And then section 3 I thought would be the hardest. Was section 3 the hardest? Or was section 2 harder for you? You've already done it. That's what I'm asking you. Are you? Oh. This is section 3. That was the hardest. Did you cut and paste, put it and compile it?
Yeah.
Oh yeah, you good. Okay. So here's the trick. So the last part of it, I think the 6 points on the bottom is going to be the most difficult. That's what I would personally think would be the most difficult. This is all regurgitation. This is all thinking. And what you've got in part number 3 is 2 points each, which is why they're worth more credit, actually. And it's only 25 points total. So we have 6 points total for this entire section, 3 questions. Each one of them, what you want to do is tell me what will be the output of the following program in Java, explain why, and you can cut and paste the code, compile it, and see what the output is. Problem is you have to explain why. So it's not a matter, and don't just give me the output. I know you can do that. Anyone can cut and paste, compile, and give me the output, hopefully. If you can't do that, you're probably in the wrong course. So the first example here goes through, and yes, it's color-coded. It came out of, when you cut and paste it, if you put it into a text editor, the color code goes away. So you won't have to edit it very much if you do it correctly. Don't put it into WordPad, don't put it into Microsoft Word, and don't try to compile this. It's not going to work. So the first one is we're creating, and yes, I did mean to repeat it twice. And this one's looking at what happens with, in terms of this, well, you'll see it. In terms of this particular functionality that we're going to see here. And I actually showed this to you in the last interactive session. The second and the third one are a little different in nature. The first one is just one program, give me the output, tell me why. And the second one is going to be assume that you have this weather class and it's stored in a file called weather.java. You actually have to break this out. You have another one, problem2 class is stored in a file problem2. So cut and paste and put them in 2 separate files, compile them, look at it, and what's going to end up happening on this one is that you don't have the driver program. So the first one, it's no big deal. You should be able to create your own driver. The first one here gives you everything. The second one just gives you the class, and gives you another one. And then it says there's 3 questions about it. The first one, what's the output that's produced by executing the following code segment? You don't actually have to implement this. You could imagine it in your head and run through the source code and do it. Or you can write a little driver program that puts all this stuff in there and just lists the output. So you don't really have to explain why either. You just have to tell me what output you get. So it's more of an exercise of figuring out what these particular method calls are doing and what's being created. You can describe this in words, so you don't have to actually put like a number or something on the screen. You just put words on the screen. So. And then the last one's actually kind of easy, I think. The last one is designing a program. And you're identifying the classes in the following description of a refrigerator. And you list out at least one responsibility for each one of the classes. And you do not need to create the classes in Java. Do not write the source code for it. You don't have to write any source code for this. And just describe in words what would you create this set of classes as described below. And you can do a couple of different things to it, but the concept is, can you actually design a set of classes? You can show me the inheritance if you want to use that. It doesn't require that you use inheritance. If you want to, designs are designs. You can design it any way you want. You can have a main controller class. You can move functionality from here to here. So it's your own unique design. There's many ways of doing it, but I want to see if you can actually put that together. Questions about the midterm exam? Anybody else do it? Or have I only got one person who's done it? You're the only one who's done it. So you're the beta tester. I hear the exam's not as hard as the midterm, as the homework assignments. So that's a good thing. That one is due for those of you who came in late on April 18th, which is our next interactive. I should keep calling it an interactive session. It's really just a meeting, our next class meeting. Now, lo and behold, what everyone has been waiting for, the CSLO essay. The CSLO essay. Did you do this one too?
No.
Okay. It's not like any other CSLO essay you may have experienced at ITU. For the new people, you have no idea what I'm talking about. For older people, I shouldn't say older, newer. New old. For existing current students, when you say CSLO, it's like a bad word. It's like foul language, It's like, don't say that in public, okay, But no, actually, we're changing the definition of it. So it's now a good word. It's a positive. Did you CSLO today? It's like, it's a good thing. Sure. Like, I could have had a V8. I could have had a CSLO. All right, so it's a good thing. All right, so it's worth 25 points as well. So the midterm and the CSLO is 50% of your grade right there. So you can do really well on the midterm, and you can do really well on the CSLO, and you could totally bomb out the final and not turn in, well, that's 50%. Now, you need to do well on the final too, and then not turn in the assignments. You end up with a C plus B, you end up with a B or so. Probably end up with a B if you do one or two of the assignments. So the trick to getting a good grade is doing the assignments. And I'll be talking about those assignments today as well. But let's go back to the CSLO. It's not due till the very last day of class. It's due along with everything else. And okay, so traditionally, let me explain what a CSLO actually is. It's a course student learning essay. Okay, so this is a programming course. Well, not really programming. It's object-oriented design in Java. It's a technical kind of computer science software engineering course. I think we'd all agree to that. Not necessarily a writing course, not an English course or anything like that. However, it is a master's level, graduate level course, which means at this particular level, you should have certain competency in terms of writing skills. So this is the only thing that's really a written essay, for which we're reading it for your format, for your spelling, your grammar, your comprehension of the English language, writing in a technical fashion, writing about technical concepts. And so it's based upon the course student learning objectives, which is why it has that CSLO. In the old days, those people who didn't like the CSLOs, it was because it took the 5 course student learning objectives from each one of the syllabuses for each one of the classes, and for each 5 of them, you wrote, how did I learn this? Why did I learn this? How do I feel about learning this? How does my neighbor feel about learning this, or whatever? It was like the same question over and over and over again for each one of them, which was kind of boring, kind of pointless, and it was more of a self-assessment. You were assessing how you felt about the learning, and it was for accreditation purposes. Even the accreditation people kind of agree that it's kind of senseless. It doesn't really, self-assessment, it doesn't really matter to me how you feel about what you've learned. Maybe pull up a chair, maybe over here. It's more along the lines of what did you learn? So we've switched it around, and actually you might have some classes, still have some classes in which some of the instructors are still using the old format. But at the beginning of this term, we were told that we can use any format that we want, as long as we keep a writing assessment into the curriculum. So here's your writing assessment. And your writing assessment is to write a 3 to 5 page double-spaced essay, just one. It's not broken out into pieces. It's just one CSLO. 3 to 5 pages, so 3 pages, this is double-spaced, so it's a page and a half. So it's less writing. It's not a bulk writing experience here. And on your selected topic, well, you've got 5 topics to choose from, and I'll go through those in a few minutes and give you some ideas about what you might want to write about. You select one of the 5. You're not writing 5 essays, just one essay, 3 to 5 pages. And you have to include 3 reference citations. That's the biggie. So reference citations would be books, journal articles, newspaper. You may use internet sources as long as you properly reference them. And then most people start thinking at this point, what do you mean by referencing them? Well, I want you to use like a style format, like APA, MLA, Little Brown Book. And if you're not familiar with any of what I just mentioned a few minutes ago, go online to www.apa, A as in apple, P as in Paul, A as in apple.org. You'll see, or just write in a Google line, APA Style Guide. It's probably the most universal guide, and it's used by a lot of schools, and some of you actually probably have been using it. Depends upon what your English grammar kind of teacher told you to use. What the APA does for you is it tells you what size your margin should be, and what size font to use. Well, anything 12 point these days is acceptable. Double space it. The format for the title page, maybe some running headers, a little reference list. But primarily for my concern, it's those reference citations. So at the end of your paper, you have works cited or references, and you have 1, 2, 3. You can give me more than 3 if you want, but you have to have 3, and they have to be different sources. Don't cut and paste a URL off of the internet and put it on your reference list. there's an actual format for referencing URLs off of the internet. You know, it's like the date received, the date retrieved, the author, the date. You know, there's a format that I need you to follow. Is the point. What format you follow, I really don't care, because this school doesn't actually have a style guide. We're sort of working on that with the doctorate program, and eventually we will have one. But right now we don't actually have one, so I can't force you to use one over the other. Use whatever you feel is appropriate, or whatever you feel is easier for you to use, or maybe you have some experience with it in the past. And at this point, you could probably use a combination of different things or come up with your own guide. But just don't cut and paste a URL is what I'm saying. And give me, author's last name, first name, the date of the publication, the publisher, regular reference citation. And your paper must reflect your own writing and cannot be copied portions cut and pasted from the internet or other sources. That is the most important part of this entire assessment, is your own writing. If you cut and paste something off of the internet, we're going to find it. Because what we're going to do is run all the papers processed through this program called turnitin.com. It's actually more of a service versus a program. It has an accumulation of everybody else's work that they've created. Fortunately for you, I don't know if he's looking for our class or not. He just popped his head in. Fortunately for you, there aren't, so this is the first time that this class is being taught here, there isn't anything in the database. So it's really only going to compare against your fellow students. So if two people turn in the same paper, we're going to catch it instantly. We don't even have to look for it. It will automatically pop up as a problem. Or if significant portions of the paper are identical, just the name is different, or you changed a couple of sentences or something, it's going to pop up. If it's 30 to 40% copied from another source, either another student in this class or the internet, that's how people write. In fact, I see high school students doing this, because I get them over at another school where I have freshmen, college freshmen. This is how they learn how to write in high school by cutting and pasting off of the internet, which is not appropriate. It's not writing, essentially. If you do that, you're going to get 0 points. So if your paper ends up being plagiarized, not your own work, you're going to receive 0 credit. There's no opportunity to redo it again. And the CSLO essay is worth 25% of the grade. So automatically, if you get 0 on that, you're looking at a C+, automatically, because you only get a 75. Then you got to do those 5 ugly assignments that I'm going to talk about, which is really bad. And then you got to pass it. In order to get that C+, you're really going to have to work hard, actually. So you don't want to plagiarize it, obviously. And it's your opportunity to practice your writing in a professional academic quality in English. It must be written in the English language, please, so that we can understand and read it. And it must include your own words, and it must be written in some sort of professional manner. It's not a memo. It's not an email message. Don't put LOL in it. I'm not going to be laughing out loud. So put like real words, real sentences. The basis of the grading is not necessarily on the content, and as it is on the format and the quality of the effort that you put into making it legible, readable. So, and that'll help you further down the road. Trust me, the better you can write and communicate, the more intelligent you sound, and the better your options are for a lot of different things like jobs and stuff. So, the more of a better positive impression you get from others. So, I'm trying to help you. That's the point. All right. So, what are these 5 topics that you can choose from? Just like the midterm, I've kind of highlighted some key concepts in each one of them. I just want to give you some background on each one of them as to what I'm looking for, and you can kind of take it from there. I've already had some of the weekday students ask me about number 5, so I'll give you some hints on that one as well. But let's start with number 1. So provide an overview of the concept of object-oriented modeling. Also discuss the concepts related to object orientation and provide some examples to demonstrate your points. Okay, so you might look at that and go, concepts of object-oriented modeling is the theme of that particular essay, number 1. You might think, well, we didn't really cover modeling. Did we cover modeling? What is modeling? What do you mean by it? Don't ask me questions like that. So what you want to do is use it as a theme. You could take and write an entire 3 to 5 page paper on UML if you wanted to. Do some research on the internet or in a library and go, well, Okay, overview. Well, the concept of object modeling starts out with these 3 different models or something, or this concept. Or you could actually focus it on a PI, abstraction, polymorphism, inheritance, and encapsulation, and not use a model as an example. Or you could come up with your own concept of what you think modeling is all about. So don't get tripped up, because here's the other problem that I find with especially international students, and the reason why this is purposely worded kind of vaguely. You take everything so literally. You told us to write about the concept of object-oriented modeling, but you didn't explain modeling. Okay, no problem. You explain modeling for me. You interpret it. You tell me what you think modeling means, and you can actually interpret it in a couple of different ways. Actually, I do not want source code. Let me reiterate the point, because I have actually seen some people who have sent me CSLOs say, "Hey, is this okay? It's source code." This is a writing assignment. It's an essay, 3 to 5 pages, double-spaced. Okay. Because right here it says, provide some examples to demonstrate your points. I don't want to see source code. Because you can actually take and create 10 pages of source code for me. Easy. You just cut and paste and write programs. I don't want to see that. I want it written out. So you actually have to explain your source code if you're using that in words, which is part of the exercise. Okay, the second one, and then stop me as we go through this if you have any specific questions, as I feel like I'm going through this kind of fast. The second one says discuss the use of Java as a web-based application tool and a cross-platform programming language. Oh, interesting. Okay, so now I've got in a special font over here, I've got web-based application tool. So you can go off on many different tangents on that one. And how you can use Java for application development, how you can use it for web-based applications, and how it's cross-platform compatible. You can focus on comparing, the pros and cons of the cross-platform, the JVM and speed, or the complexities of looking at it from a networking point of view, designs of programs. And in fact, for all of the networking people who love the internet and web development, that's your question, probably. That's the one you're going to focus on. Provide some example benefits and a general discussion about how cross-platform technology works. Hopefully, associated with Java. If not, you can how regular old cross-platform compatibility works and how the Java JVM actually kind of fits into that concept. So that one is kind of similar to the next one, number 3. But number 3 specifically wants you to talk about the EE, enterprise computing. So number 3 says discuss Java's growing importance in client-server computing and provide an overview of the Java EE, enterprise computing environments, and the Java client-server computing environment. Don't give me an Echo client server source code. Write it out. Tell me why it's important to have the platform, what the platform is used for. What is your critique of the platform? What kind of tools does the EE provide? For all you people who like client-server, some of you may have even taken my client-server in the internet course. Describe that course, essentially, and everything we covered. That would be a good answer, actually, to that question. But that focuses on the EE. Maybe I should have put that in this kind of a font, but that's really the purpose of that question. Number 4 is the de facto standard. This is the one people are going to plagiarize. This is the one that's easy to plagiarize because every single Java course asks the same question in terms of any type of an essay. And it's, compare and contrast the object-oriented programming language with another object-oriented programming language. And it's usually Java and C++. And do not put together a chart that says Java on one side and C++ on the other side. And here's all the features, and that takes up a page or so, and then another page with source code that shows you a class in C++ and a class in Java. That's not going to work. We need words, okay? And you don't have to answer all of these questions. How do object-oriented features differ between the languages? Is one language more object-oriented than another? Are all object-oriented features implemented in both languages? Does one language support something that another one does not? I put this question in for all the newbies. If you're a newbie, you probably are overwhelmed at this point anyway, and you're probably thinking, oh, this was an easy one, number 4. For more experienced people, I don't know if it's really a good choice for you because you're not going to really learn anything. And if you just want to get it done, great. If you go on the internet and put compare object-oriented programming with C++, This is the one that I'm going to catch most of the plagiarism on. That's a red flag right there that says I've plagiarized. So number 4, not to say so number 4 is going to be critiqued any more so than any of the other ones. I'm predicting ahead of time I'm going to get the biggest hits on Turnitin.com with that one. There are millions and millions and millions of papers out there on the internet. Every student has had to write one on the comparison of Java with another programming language, object-oriented programming language. So use that one with caution. If you're a newbie, it's a good choice. It's your way out. If you're an experienced Java programmer, don't pick that one. I mean, you have every right to, but not a good one. And number 4 is the one where I'm going to catch everyone who doesn't want to write a paper, who's going to instead describe a design, and who's going to accidentally give me too much source code. Because here's what's going to happen. You're going to demonstrate how to solve a given application problem, by going through the steps of program design within the context of the object-oriented paradigm. You do not need to create a Java source code, but provide the logic for the program design and explain why it's a good design and how the object-oriented concepts are applied. I have actually one student who asked me, can we take the refrigerator from the midterm and use it? Yeah, actually you can. You can actually explain how you took the refrigerator example and turned it into a program. Using text, using words. Do not describe a project that you're working on that is just a generic description. I think we need another chair. We actually kind of filled up a little bit, which is not bad. I don't want to know about the software development life cycle. I don't want to know about, it's not a software engineering question, what methodology you used. What I want you to do is take an example of a problem like the refrigerator, last question of the midterm, or something similar to it. Maybe I want to create a program that works in a dental office to keep track of dental patients. Describe the object-oriented design and the approach that you would take in the object-oriented design. In the design and given the application problem, go through the steps of the program design.
So you can pick
any problem you want, and go through the steps of the program design. How would you identify the objects? How would you look about the relationships or the association between the objects? Pick up a UML book or a design book, or go on the internet and look at object-oriented design and think about some of the methodologies that are used. There's noun abstraction, there's CRCs, there's all sorts of different ways of identifying objects, putting the objects together, designing the interface between the objects, the public, the private interfaces, what objects is going to be responsible for this, responsible for that. And take a look at the lecture number 11, the last lecture that I pointed out a few minutes ago. That one covers design as well. In fact, I'm going to take a poll at our first break and find out what you guys want to learn about, and then we'll figure out which lectures I'm going to cover, depending upon what the demand is. But big picture, it's your opportunity to explain, and to research and to figure out design methodologies and approaches. Don't write source code. Don't simply explain, I'm going to use a waterfall model. I didn't know, it's not a software engineering question. It's a design question about object orientation. Talking specifically about object-oriented design classes. So number 5, I kind of see as a potential misconfusion. People saying, well, you told me about the design. Here's my design. That's where you go back up and you read the word essay on the top of the assignment description. It's an essay. But some people might not enjoy writing, abstractly about concepts. I feel like they're writing reports, or they're writing. And so number 5 is actually kind of the opportunity to write it more like a technical manual almost. Here's the way I'd go about the design. First, I'd look at all the nouns in the words or something, and then I would take these nouns and turn them into classes. And here's an example. I have this description of this refrigerator, and here are the classes that I would create. And the only reason why I come back to that is it's actually, when a student mentioned that to me, I'm like, oh, that's not a bad idea, actually. If you got to do both assignments, you already got a description. You're already creating the object-oriented design. Why not just turn that into 3 pages, double-spaced, page and a half of description? And that way you can cross-check your answer on the midterm, along with some further thinking. So if you want to take that approach, you can use that same theme. You can use any theme you want. You can come up with your own theme. You don't actually have to write out a requirement spec or something like that. You don't have to give me, you want to briefly though, you want to briefly give me, so briefly describe what it is you're designing, essentially. And then, why is it a good design and how are the object-oriented concepts applied is the focus of that. Questions about the CSLO essay? Nope. Okie dokie. That's what I like. No questions. If you do, you can always send me an email message. So for those of you who came in late, we covered the midterm already. It's due on the 18th. CSLO essay is not due until the very last day of class. Now what I kind of want to do is, I've got a couple of objectives today. Number one, I want to talk about the assignments, the programming assignments. And then I want to hit a little bit of the lecture stuff on some of the topics that are important. And I kind of want to do them both together. Last time we met, we went over assignment number 1, I hope. Did we go over assignment number 2?
We did.
We did? Has anyone actually done assignment number 2 outside of you? Did you do it? Was it easy?
Yeah, it was easy. One method, like assign students or something.
Yeah, find students. The static method.
It was kind of tricky, but still interesting.
Well, then I'll take a poll. You guys want to
And
know?
also, like, we have gone through the third one. We have just had a glance at it. Saying,
Okay.
like, we're going to cover it in the next class.
Okay, good. So that's why I like refresh my memory here. So
Like, we just went through
the
it.
third one was on collections. Yeah. Well, I guess let me take a survey, a show of hands, maybe. Good starting point. How do we feel about inheritance? How many people want more information on inheritance? Raise your hand. Just 2, 3, 4. Oh, the whole front row wants inheritance. You want inheritance too? Do you want inheritance in terms of helping you with the assignment, or do you want inheritance in terms of concepts in a PowerPoint? Both?
Assignments.
I think assignments makes more sense, actually. So those people who did assignment number 2 are going to be extremely upset with me. But you guys actually know more. So these guys who need extra help with it, this is for you. So let's take this approach. Let me do this in a practical kind of means. Number 1 is Hello World. You guys probably got that one, I hope. You created a class, a single class. So instead of giving you boring PowerPoints, because here's what you can do for the boring PowerPoints. You can go online and you can listen to all of the weekday lectures of all of the PowerPoints. And they're very clear because they're recorded on my computer here. You can hear me, you can see it. I'm going to go through probably slower than I would if I crammed in about 5 or 6 PowerPoints into you today. Because each one of them is like an hour and a half each. So I think it's more efficient for you to kind of look at concepts that you might be interested in. So what I'm going to do is give you inheritance. So I'm going to talk about inheritance, put it down into programming language terms, and at the same time, apply it to your second assignment so you know what to do with it. Of all the assignments, this one and the last one, I believe, in fact, actually I didn't think the last one was so bad, but this one is probably the worst. This is the hardest one. Huh? You done with all of them?
No, good. This is the hardest one I've done.
Yeah, you're done with the hardest one, yes, the hardest one. So what we'll do is we'll start in here, I'll go for about a half hour, we'll take a little break, and then, because you guys are going to have information overload soon, and then we'll come back and we'll finish this, and we'll go through the third and the fourth. And good for you, also, I put out on the internet, on YouTube, a video that actually goes through the code. So as I'm going through this, don't be concerned with writing stuff down. Don't copy, because I'm giving you not everything, but I'm giving you a good percentage of this assignment. And I'm going to show you the code for it. Because I have to show you the code because I need to talk about what it's doing and explain to you how this inheritance is working, which I think is the best with an example in real source code. But while you're standing there, what I'm trying to tell you ahead of time is don't write it all down, because you actually can watch this video after the weekend's over with. And you can see all repeat. In fact, if you came in late, you'll see the midterm and everything, all the announcements I made up front on the video. So, all right, I2U. In fact, this is interesting because I've already seen this on the internet a couple of times, where students have posted on forums, the assignment, wanting the answers to it. which is ridiculous because it sounds like an assignment for a class. Nobody in their right mind is going to give you the answer to it. So I know the students have already tried to plagiarize this or have tried to cheat with it. And those people who have actually searched on the internet for the answers to it have noticed that, oh, it's used for another class over at actually 2 other universities, Ohio State and another in the East Bay. In fact, we use this at Cal State East. It actually comes out of a book. So I know that the assignment is solid. In fact, all of the assignments come out of sources. I did not actually create any of these assignments. They're published assignments that a lot of teachers use because they're really nice in terms of showing you. In fact, this assignment shows you everything there is to know about object orientation. And it does it in a really interesting way. We're making you think about the design, but what you're really doing is implementing abstraction, polymorphism, and inheritance encapsulation. You're working with interfaces, you're working with abstract classes, with static, which is the class method variables, with instant methods variables. You're working with inheritance through multiple line. You're working with the concept of the object. And you're taking the object that's a person. Because what the goal here is actually kind of, in terms of the assignment, is it covers everything. This could be a great final exam, actually. It's not. It's just a programming assignment. And for those of you who thought it was really difficult, who have looked at it already, when we're done today, you'll see, oh, it's not that bad. It actually isn't actually that bad if you apply the concepts correctly. The problem is some of you might be a little weak on some of the concepts, which is why I put the assignment in here, which is why all of the assignments are challenging, to say the least. So, all right, so ITU wants you to write some classes for their personal record system. And to make it easier, you're going to have 4 classes. Okay, so here's our inheritance. In fact, the little picture here kind of shows it to you. So the following figure illustrates the relationship of the 4 classes. The person class here on the top is the parent, and we have an employee that's also a person. We have a student that's also a person. And we have an instructor that's an employee that's also a person. So when we create an instructor object, it's also an instance of an employee object, and it's also an instance of a person object. And when we create a student object, it's just a person and a student. It doesn't actually contain anything about an employee, it's a student. So we can kind of see how the lines of inheritance work. What we're going to do is build this in a program design. And I'm going to show you the source code for it. And for those of you who go, oh, what do you mean? You're going to give this assignment away? I've already spent hours and hours doing it. And she's just going to give it away. I'm going to give most of it, not all of it. I'm going to leave you with some homework for you guys who have not done it. And it will require that you actually understand the concepts in order to implement it. And you might guess it's the find students, which is the most difficult part. I'm going to show you find students, but I'm not going to show you the other half of it. So you'll have to understand it. You'll have to actually download. And I'm not going to give you the files either. You'll have to type it in yourself. You'll have to create it on your own. But what I want to do is kind of teach you the concepts, because this is really much everything we've covered in the course, everything we should be covering. Okay, so the following are your tasks, and you need to complete each one of these classes. So obviously these classes are these classes, 1, 2, 3, 4 classes, plus a driver program. When we give you the driver program, I'm giving that to you. So the classes that we're creating a person, an employee, a student, and an instructor. So let's take a look at these classes. And lucky for you, I've already created it, so I can just show it to you. And I can zoom in a little bit here and make it so you can actually see it. I put it into Eclipse. If you're not familiar, or if you don't have Eclipse installed, I highly recommend using Eclipse, actually. In fact, if you go online and kind of look at people's examples, half of them are in Eclipse. It's free. It's easy to use. Oh, what is this, assignment 2? Yeah, here we go. And I'm going to do the same thing for 3 and 4. So, because I think it's easier to kind of see it implemented and have me talk about it instead of showing you PowerPoints. You can read the PowerPoints on your own. All right, what's wrong with my mouse? Open project, how about that? Oh, I probably had it open like 5 times right there. All right. If you're not familiar with how to open a project, we covered that last time. How to create a project, how to import files into a project, we covered that last time. Let's start out with person. Person. There we go. Let's make this bigger. Hold on one second. You guys are I know you guys have good eyes, but this is even better. Oops. That's pretty big, huh? Ooh, that is really big. This screen is not as big as my screen. How weird. Okay. So the screen on the projector is not as big, so I have to remember to scroll this way for you. Okay. All right. So, abstract classes. Have I covered abstract classes in this class? Some of you are shaking your head yes, some of you are shaking your head no. I think we did, actually. If we didn't, let's talk about abstract. Abstract means that we're going to, every time we have an abstract method in an abstract class, if we create an abstract method, we have to make the class abstract. An abstract class really doesn't mean anything. It's just a default standard that we have to actually put the word abstract here. Otherwise, our compiler is going to give us an error. If we have an abstract method, what's an abstract method? An abstract method is if you're a C++ person, it's kind of like a function prototype. Methods are implemented in the term of functions, and I'll review a little bit here. These functions, we don't actually have to implement them. So we know that we're going to have to print out information about each one of our employees and our staff, and actually there's no staff, teachers and instructors and students, and each one of them is going to have a toString method. So, and we know we're going to inherit from person, although we can easily, well, no, we're going to inherit actually every one of our classes from person, because person is the base of all of this. So this is going to be used as a base class. We do abstract to say, well, I don't want to use the word template, but that's the first thing that comes to my mind in terms of what the concept is. It's abstract because it's wide open, abstract. What does that mean? High level of detail. Something that's abstract is an overview slash covers a lot. It's vague. It's abstract. It's not a definite, fine printed class. So we have a method in here that maybe I made it too big. There we go. That's a little better. Which is going to be an abstract. And this is an abstract method that doesn't include a method body. Instead, we have said public abstract string, and we're going to call it toString. And we know that this is the data type of the method, which means that this method's going to return a string in terms of what it's implementing. But we don't have a message body at all. So after we create the class, we have to populate it with some information. Let me take a quick look back here at the description. Maybe I made this too big. I think I made this way too big. Can we shut that door? Because now we got someone talking on the phone in the hallway. Okay. All right, person. The person has an ID starting with 1 and should be unique. So every person that gets born into this environment is going to have its own unique ID. And it's going to have a name. That's going to be, for all people we have, well, we have social security numbers and we have names. And every one of our social security numbers is our number, so it's unique. So what do we have up here? We have public integer ID. This is the ID for each one of the integers. That actually probably should have been private, but I made it public. So my access methods, in fact, I was reviewing this for a YouTube video that I've already made on it, and I noticed that already, but I didn't change it. I still haven't changed it. I just left it alone. But it kind of shows you have a choice. But by default, as I mentioned in the first meeting, our data members are all private. Our member functions are all public. And so we manipulate the private data through the public interface. And that gives us our access methods, if you're not familiar with that. And then we have the person's name, private string. This is more standard. I set the person's name to unknown. Otherwise, if we create an object and we don't have anything assigned to it, we didn't assign a name, it's going to be null, or it's going to be, actually, it'll be null, actually, because the object itself won't exist. The member inside of the object isn't going to exist. And we have this thing up here called a maximum ID, and I have this marked as static. And so here's a review again for what we should have covered last time. The concept of, and this assignment lays heavy on this concept, that we have instance variables, instance methods. Then we have class variables and class methods. Anything from an instance level is called on an instance of the object that's created. So if we took person and said person, new person equals new person, we created a person with this, or that's one way of doing it. Then we would go new person dot something, run a method, new person dot get a data member. What we don't want to do is new person dot ID, because now we're getting at well, this one's public, we can do that, but in fact I made it public so it's easier to do that. What we would normally do is new person dot get ID, set ID. And these are the methods that we've created in the class that say set name, get ID, set ID. Because we're taking these methods which are public and we're changing private data members about the class. It protects the data so that the data can only be manipulated the way we originally intended for it to be manipulated. And in this particular case, it's being manipulated per each instance. So when we create every instance of a person has their own name, has their own ID that's associated with that instance of that object. Now we can, and if you remember last time, I covered actually the concept of class variables, class methods. So that's when we step out of the instances, and now I usually reference this God example where we play God, where we go in and we look at all these objects and go, I'm going to control you, you, and you, and I'm going to set information that is known to all objects automatically for all objects through a class level instead of an instance level. The scenario in this program, and in fact, some of the people who have actually done the program who still didn't get it, was that we're doing both. We have God out there, and we also have all of the instances of the objects that are going on, and we're playing with both environments simultaneously. The theme of the program is that we have a person, and the person can be an employee or they can be a student. The employees can be janitors, staff, or they can be faculty or instructors. So we have multiple roles that are taking place that are, and all of these people are people. They're all persons. And when we create them, as an example, we create a student. And we'll see, and I'll show this to you as we get further through the example. This student, when we create it, we have multiple constructors. We can create a student with a name, with a teacher ID, or we can just create a student. Or we can create a student with just a teacher ID, or with just a name. And then the student exists. But then we're also creating a teacher, let's say. Or maybe we're creating a student and the teacher doesn't exist yet. So the class level stuff, the God environment, looks down after the fact, after you've created all your instances of variable options, and cleans up the mess. It takes all the students and assigns them to instructors. Takes all of the instructors and finds out which students are associated with them. And that's the class level method, the find students, that is the most confusing part of this entire problem description. And I'm going to explain that to you. Actually, I think I probably just did. So you kind of see where it's coming from. It's really playing with class and instance level information. So let's go back to person, finish that up, and then we'll take it through the steps, and hopefully you'll see this come together. So these are the data members that are associated with person. And we have this toString, which means every class that we derive from this class, this base, every class we build on it is going to have a toString method to print out the information. In here we have a default constructor called person. Person, we're going to keep track of the maximum ID. We need to know, because each student and each instructor, each employee, everyone's going to have their own unique ID. We're not using a counter for this. So don't implement counting and don't implement any. This is a static variable. This is a class level variable that keeps track of all of the people that are created. And in fact, in real life, that would not be a bad idea, actually, because then we wouldn't have identity theft. Each person would have their own ingrained ID. We do. We have fingerprints and things, but you know what I mean. That's really much the same concept. And so what we're doing here is we're incrementing on each person this static variable. It's static, so it can be shared among all instances that are created. We're going to call it maximum ID, because the assignment has us call it that. Where we take, and it's an integer value. So the first thing here in the default constructor and all of the other constructors that are created are going to increment it. So on every person, we start with 1, we increment it, because, well, actually, we didn't start with 0 here. The first one is number 1. The second person is number 2, etc. And then we're going to set the ID for each person. So we have this counter, if you want to call it, maximum ID that controls all people. And we have to assign the one that was recently created to that person. So here I'm using, and we don't actually have to use a separate function for it. We could have just assigned it, but I used a set ID because we're going to use a set ID, a get ID. If I had made that private, I wouldn't want to just arbitrarily change it, and I wouldn't want anybody else to change it. So here's where we get the accessors and the modifiers, if you remember from the first class meeting. Talked about that. Where we get something, we set something. So the get's going to return an ID, the set's going to set the ID. So this is where we see the this. It means this instance of this object. We're setting our ID to the ID. And so in here, to get the maximum ID, we're just returning it. So you might look at this and go, well, that's a lot of work you got on here. And the methods really aren't doing anything. Well, it's setting a template for a good design is what it's doing. It's making sure that we have access and control over how we're setting and we're getting the data members. I believe there's a problem with that door.
I guess so.
Yeah, it seems to be locked or something. So. Any questions on the basic structure of the person? This is the base class that we're going to use. If you don't understand person, you're going to be lost from the next class up. So it's a good thing to ask questions earlier than later as well. Okay, so we have person, and now we're going to create an employee, and the employee has a salary, and the salary is going to be a double and should not be negative. All right, so this seems pretty straightforward. So let's take a look at the employee. And then obviously, just to review, capital. Believe it or not, I say this all the time. It's the same thing with both the private and the public. I always get students to send me lowercase, person all lowercase. Right? Nobody else to capitalize anything. If you capitalize the object, then you really know it's an object. It's a naming convention. It's very standard, actually. So person should have a capital P, and it's saved in a file with a capital P, actually, because it is case sensitive. All right, let's take a look at employee. All right, so now is our review of inheritance. As we mentioned in the first class meeting, we have employee, class employee, public, obviously. Extends person. That's our inheritance 101. We use the word extends to say we're inheriting from person. So a person has a name already. So what's different about an employee? Well, they have salary. The person has the name and the ID. We're going to use that in employee. We don't have to reinvent the wheel. Because still, I see students who put, string name, integer ID. If you do this, what's going to end up happening is you're going to have two IDs, one in person and one in employee, because you already have the ID. So use what you got. So really all we're doing is we're adding, and this is more standard here, we got the private double salary, our only data member that's associated. And the assignment actually kind of helps you because it's telling you specifically what to put in each one of the classes. I wouldn't go overboard with other things that don't belong. You do have academic freedom to modify stuff, modify the names of the variables, modify anything you want. That's okay. But try to follow the same concept. So now we have our constructors, and our assignment description specifically said we needed to have non-negative numbers. So we're going to set it, salary is equal to 0. We could put some logic in there to put a check on when we try to set the salary, make sure it's not negative. But we're going to assume, and in my implementation I've kind of left out error checking entirely. We're going to assume that the salary is going to be a valid number that's given to us. So you can certainly add error checking if you'd like to your program. I'm not going to remove points if you don't have it. The point is I want to see the object-oriented stuff. So now we have 3 constructors, and you learned how to create those constructors over and over again in assignment number 1. So assignment number 2, you should be familiar with this already. What do we have? We have one that takes on the name. So we can create an employee with a name. And here's where super's coming in. So super is running the constructor of person to set the name. Because in person, we have, I should have closed it. We have a constructor, here it is, that takes name. So super says, go back, oops, student, I'm sorry. It's the same, well, we have it in all of them. So There it is, person. It's a string name. And the string name in this here is setting everything for us in terms of, so what we're doing here essentially is we're saying, super says go back up a level and run person's constructor that matches. And they call it a some people call it a footprint, some people call it a template, some people call it a marker. I don't have a word for it. I just say, run the constructor that matches this one. And what have we done here is essentially we've overloaded. We haven't overwritten. We can't overwrite, and here's an answer for the midterm. You can't overwrite a constructor. A constructor exists in a class whether or not you inherit from it or not. And all of the constructors will go off automatically on every new instance of every class that's created. So when I create a new employee, I'm also getting a new person. And all of the constructors are firing off. So if I've written a constructor here that says employee, that says, and I've overloaded it, I've modified it, because now I'm taking in, well, here if I modified it here, I've taken in a double salary as well, because employees have salary. Here when I say super employee, I'm going, go back, I'm saying ignore me right now, go back to the person and run that person constructor. And it's going to do it automatically, but it specifically, this explicitly calls it instead of implicitly. You don't actually, a lot of programmers never like super for some reason. A lot of people don't like this either. But super is really handy because you can super back, if you want to call it that, or you're going back. You're going back and you're running something that already exists. Because what do we don't want to reinvent the wheel. We want to assign the person's name to the employee name, because it really belongs as a data member for person. And then here I'm just printing something out to the screen. And I've put this printout in here. I guess I'm going to show you the output of this, because really the only way to really see this work is to examine the output. So I'm going to print out employee was created with an ID, an ID. We don't see anything in here about any ID. No ID is being created in employee. No ID is being created in a student or an instructor. No IDs. So IDs are part of person. Every instructor, every employee is a person. They're going to have an ID automatically. But I can go here and I can say ID, print out the ID. Well, actually I can do that because I made it public. So that's how I essentially worked it out so I can put my print messages to the screen. So, which is why I changed that to public, but it's no big deal. All right, so that's a constructor number one. Constructor number two takes on the employee with a salary, so we can actually populate. We all know why we have multiple constructors, so we can take in a variety of different information, automatically set the data members to those values and use them without having to go back and reset them. All right, so we have a super employee. That should look familiar hopefully right now. We have set salary to salary. Set salary is a method that we have put inside because we don't want to go salary up here is private. We want to keep things controlled through the methods that we're creating. We could have gone this.salary is equal to something, but instead we're going to set salary. So set salary is right here, and set salary going this.salary is equal to salary. If you don't want to put the method in there, you could cut and paste this, put this up here, and have this dot. We're just setting the contents of that particular data member, and we're just printing it out to the screen now. Employee name was created with an ID and a salary, so we can know that that constructor was built. And then we have the employee without the name, just the salary. And then we have, so we could get some nameless employees here, but person, we would actually have to put a default name in there like unknown, which is why I put that unknown. Because if we ran employee, we created an employee as an example, and we just gave it a salary with no name, then what would end up happening is the name would be unknown, because up here I have string name is equal to unknown. And we haven't set any of it. We're not running any constructor here, so we're not going to set the name, essentially. The name's not being set. So that's why some people put some default values in there. Okay. So let's see where we end up here. We have some trivial stuff. So set salary, get the salary. And lo and behold, because we're extending one class from the other, we have the implementation of our toString method. So we've created a toString method. In this particular case, we're using text. Actually, we don't need it. So this is trivial. So some people will probably never catch this, but they'll look at this and go, well, why do we need a toString method? And it's to get you to create an abstract class is what it's all about, and use an abstract method, because we're going to require this. So why would we not? Why would we want to use that? Well, let's say, for example, we needed it, and we wanted to tell people who inherited from our classes in the future that you're going to need to convert this to string in order to print it to the screen. And this is a function you're going to want. It's almost like an event-driven program. It's like, listening for an activity, capturing the activity. All this stuff's the same as rudimentary. It's all, repeated over and over again. That's why you make abstract methods. So if you leave it out, it's kind of like, hey, you left it out. So the compiler will come back and say, you need to implement this method. You're not done yet. So it warns the future programmer who extends the class in the future that they're going to need to implement that functionality. That functionality doesn't automatically exist in the class, which is what the toString is all about. And so that's employee. Let's go back to the description and revisit that for a second. Huge. I think this is getting bigger and bigger. All right, so we have employee. Now we have student. Student is going to have a teacher ID, and they're going to have a name, teacher name, and a teacher ID. And then actually we'll cover here instructor is the other one. Instructor, actually let me cover student real quick, and then I'll go back to instructor, because instructor is the hardest one, actually. So we got the employee, we got the person. Let's see. So what was going to do? Student. Here we go. Student. Now this was a piece of cake. It'll go fly by because this is just the same as an employee. Essentially, we have public class student extends person. You should be familiar with that already. What do we have now? We actually added the student name, the teacher name, and the teacher ID. Good. Perfect. We don't need a student ID. We have one already. It's the ID. We don't need a student name either. It's in person. So person and ID. Name and ID are already in person. We already have that. Here's our constructors, and hopefully this is starting to look a little familiar to you. Every class you create looks the same. It just has different names, different number of constructors, different number of parameters. Here we have student, and we have a student name. Looks like employee, taking on an employee name. We're going to super back with the student name. That should look familiar. So every one of these classes pretty much follows the same format in terms of our functionality. This is different. This teacher name is equal to unknown. We weren't given a teacher name. We weren't given a teacher ID either. So unless we set it, if we don't set it, it's going to come back. Can we bring another chair in? Here's a big one, comfortable one. Oh well. If we don't set it, we're going to come out with null values. So it's customary to kind of take a look and say, well, let's set it to unknown, and then let's set the ID to 0. As an example. And then what we're looking at here then is just a print out the information to the screen. And now we have student. And with the student name, the teacher name, and here's the part that most people look at and go, oh, this is the hard part. So far this has been fairly straightforward, I would think. Hopefully. If it's not straightforward, go back, redo assignment number 1. We've done all this stuff already in assignment number 1. This is the new part. We're passing to the constructor an array of people. And we're creating this array of people in our driver program. So let's take a quick look. I'm going to stop with this one for a second. Take a quick look at the driver program. I've removed some of the comments out of here so it makes it a little easier to read. I'm going to hope you guys can see this here. In here, the first step, we've created an array, and we've called it person array. And we put a maximum head count of 20 in there. We don't have to. We could have just made it arbitrary. But the concept is, and if you're not familiar with the concept of creating an array, get a DDL and DDL text. That's basic programming. That's basic Java. That you should already, hopefully, if you're not, you can learn it simultaneously through the course, but it's easier if you're already familiar with it. So we have these opening, you can see it, this is an opening and closing bracket, which gives us, this is a data type of an array, which means we store more than one. So single variables, store one of each object. We can create an array of objects, and they're all of the same length. And all of these objects are people. They're all persons. Some of the people are teachers. Some of the people are staff, or employees. Some of them are instructors. But they're all people. They all got inherited from person. Actually, they all got inherited from object originally. but we're dealing with them as people, which is why we created an array of the people data type. If you get an error message in your program that says, do you want to typecast to person? Don't do it. There's no typecasting required. Because every employee that gets created is a person. There's no need to typecast them. They are a person. They are an employee and a person. Instructors, all three. It's an instructor, an employee, and a person. And so the object here is that we have objects that are instances of objects that are enclosed inside of other instances of objects. And all three exist, or all two exist already. There's no conversion from one to the other. Instead, what we do is we call the object by how we want to address it. Are you a student? Are you a teacher? If so, then run this method on you, or run that method on you. We explicitly declare the object type when we try to run a method that's not part of person, and I'll show you that as an example if you didn't get that. But what we're doing is we're creating an array that we're going to store all these people in, and then we're creating the people. So when we create the people, in this example, we've got person array at index item 0, and they're going to be equal to a new student, Peter. All right, so we know what a student, we've seen the student already, and we're sending it Peter, so we have a name and we have an ID set for Peter as a student. And then we have an instructor, Peter. So you might be thinking, ooh, what? That was done on purpose, actually, because we have to keep track of the people by the only piece of information that we have that's unique. Don't use their names, use their IDs. We have a Peter number 1 and we have a Peter number 2. Peter number 1 is a student. Peter number 2 is an instructor. So tells us we can't use if the name is equal to Peter. No, we can't do that. All right, so now if you notice that we just used the name so far. So instructor Peter doesn't have any students. In fact, we have no way of assigning students to instructors. Instead, we have set we haven't looked at instructor yet. I'm going to look at that in a few minutes. We're going to create an array of students that are associated with each instructor. But to start out with, and not to go too far ahead, we've created a student, but we haven't assigned a teacher or a teacher ID. In fact, we can only assign a teacher name. We get the name automatically from the teacher. We can get the ID. So as long as we know the name of the teacher, then we can get the teacher's ID. That's sort of the ID. But you can probably kind of foresee a situation here in which, we have the freedom of using these constructors. We have the freedom of creating these people. We're loading these people every time we create one, and this is easy. We're not using a loop or anything. We're just going item number 0, item number 1, item number 2. And we're populating the person array with these items. So we have all these people that we're creating, and we're putting the people in the person array. So we have the instructor, Sandy, salary 2,000. We have an employee, Bob. Bob's and everything. So we have Peter. We have a student, Tom, with an instructor, Peter. Well, Peter existed. That's good. We have a student named Maggie, and her instructor is Susan. Well, we don't have a Susan yet. We don't have any instructors. We don't have any people created that are Susan. It's almost like being assigned an instructor who hasn't been born yet, which is kind of a weird phenomenon, but it does occur in programming. It doesn't occur in real life. So here we have an instructor named Susan and her salary. Oh, there's Susan, but Susan was created after Maggie was created. So hopefully you can kind of see what's going on here. We have students that aren't assigned to teachers. We have teachers who aren't even aware of what students are associated with them. That's where we come in with what I call God. We come in above the picture, outside of all of the instances of all of the classes, and then we start controlling them at a class level instead of the instance levels. So far, all of these are instances that are created of each one of these classes. Then they're nice. All these objects are commingling, all communicating. But we have a situation in which some of the objects aren't aware of the other objects. Like Maggie, Susan wasn't even invented yet. Now we have Susan. So we have to fix it after the fact. So what we end up having then is a case in which we have to fill in, and what I've done for you is actually shown you how to find students. I'm not going to show you how to find teachers. You actually have to create that on your own. It's the same functionality. You're just doing it backwards. Instead of the instead of the teachers finding the students are finding the teachers, which is basically both parts if you think about the concept. So we have this method, and we're calling this method at a class level because we're going from a class method called find students that takes an array of all of the people that we've created, and it's going through and it's modifying all of the objects from an instance level, but it's doing it outside of the instance. Instead of these people trying to figure out everything, it's like the manager coming in, overseeing the situation and telling people what to do. You're part of her. Okay, you have all those students. Populate your array with all the students. You're a student. There's your teacher. You know, we're going to assign you. And so that's what's meant actually as a class level variable versus an instance level variable. And then you'll have to create one for the student, and we're printing it out, and then we're going through the loop, and each one of our methods has a toString. So it's going through and it's going to print. Actually, we're not even using. Nope, here's the toString. So we'll print out the person array.toString. So we can do that because we know we have a toString, which is why we put the toString as an abstract in the abstract class person. We created this method because out here in the driver program, all of this stuff that's inherited from person. We only have 3 people right now. We have employees, we have, and all this stuff. We know each one of them has a toString automatically built in because we made that part of the abstract class. So we know it's implemented. It has to be implemented. Even if it's empty, it's implemented. Which means out in the driver program, we can run something on all of the classes and know that if it's that particular inheritance line, it has it. So we can run it. Which kind of gives us more logic that we can use outside of all of the instances. We know it's there, so it helps us with the concept. So let's go back to a student as an example. So student here has this constructor that we're creating has the opportunity of taking on a person array. We have the array out in the driver class. We know everybody that we've created so far has been added to this person array. We've sent the person array as a parameter to the method with the student name and the teacher name and the person array. Which means in this particular constructor, we're going to take the person array and we're going to find the teacher and assign the ID for that teacher, given the teacher name. Because what we're given here is the name of the teacher. Maggie was Susan. Yeah, Maggie's the student. Susan's the teacher. Susan's not in the array because she hasn't been created yet. But if she was, we would find her and we would get her teacher ID and assign it to that particular student. Let the student know about the teacher's ID is what we're doing. So this is familiar, hopefully. So bring back to the student name, setting the name for person. This teacher name, we've got it right here. And so we're doing this here. This teacher ID, same thing we've done in the other constructors. Just in case we don't find anybody, we set it to 0. Because it's kind of not a good idea to have null values all over the place. It's 0, you know it's not set correctly. So unless one is found and assigned next. And so now what we're going to do is find, this is why it's called, well it's not, it's in the constructor, but this is the same routine. In fact, this code is used 4 times in the program. For students to find teachers, for teachers to find students, and then after the fact to clean up the mess on both ends. So here's the first instance of it, and this is the part where I said it's kind of interesting to see. And what we're looking at is this instance of. So we've got this person array. The person array has students in it. They're all people. It has students in it, teachers in it, employees in it. But they're all the core object of a person, which means they're all equivalent, which means they can be stored in this array. Here we're going to say for I is equal to 0, I is less than person dot maximum ID, get maximum ID. This is coming back and saying, well, that static variable, if you remember back in the beginning when I showed you person, we had a variable called get maximum, we had a method called get maximum ID that returned a maximum ID. That was a static, it was a private static integer. This is a class. Person is the name of the class. We're not calling it from an instance, which means We're outside now, we're the manager, we're outside of the environment. We're like, get that maximum ID. So we got it. So we can use it. We have 12 people. We have, actually in this case, we ended with 7, I think, total. But right now we only have like 4, I think, 4 or 5 at the most. Maybe we have 3, I don't know. So if the person array, so if the guy who's in I, which is going to be 0, 1, 2, 3, 4, according to our loop, is an instance of instructor. So instructor is a class type. If we can call a method on the object and say, give me your class. But it's assumed actually in terms of the logic when we say instance of instructor. So we can say instance of employee, instance of person. Well, they're all persons, they're all people. So if we can check the type of object that is, and say if it's an instance of an instructor, then, because we're only looking for teachers, right? Otherwise we're going to find Peter. This is what I was trying to tell you. There's a reason why we have Peter as a student and Peter as an instructor, or as a teacher, because we can't rely upon just the name. This comes in handy for a lot. When you start using inheritance, you got to be able to figure out who's an instance of what in order to sort the information out. Here we're using it to find the instructors that are in this people array. And if it is, then get the name. And if the name is equal to the teacher name that was provided for us when we ran this constructor, then this .teacherID is going to be equal to the get the ID of that particular object that we found who's an instructor who matches that name. If not, it's not going to be in there. Well, Maggie's not going to be in there. So, or no, Susan is not going to be in there at this point. So it'll work on one of the other ones though. And then we print out the information to the screen. And then here we have the get teacher name, get teacher ID, trivial stuff. And look at that, lo and behold, our toString function. Because every one of the classes that we've extended from person is going to have a toString function in it. So don't worry if you're wondering when I'm going to stop. After we get done with this example, because I think you need to see it all in one sitting. Otherwise, I'm going to have to go back and re-explain. Then we'll have a break after that. So hold out until I get done with the example, and I'm getting very close to it, actually. Then we'll break. So let's see, what do we got going on here? Instructor. So we have the student with the teacher ID and teacher name. Instructor. Instructor's a little different because we don't really need anything. We already have the name. We already have the ID. And we know by its ID, because we've assigned a teacher ID to it, that it's an instructor. So what we need, though, is an integer array. Now we're saying that each instructor can have up to 10 students. And we're going to zero out, assuming that you can't have more than 10 students, we're going to fix it. Because arrays, and we're going to show you after the break, when I start looking at the next one, arrays are fixed numbers. We create an array of a particular size, and we can't go past that size. So we have array lists, which is a built-in part of our container classes, or our what's the word for it? Well, container, I guess, it pretty much describes it. We have, in Java utilities, we have data structures that are built in for us. We can create linked lists, we can create array lists, and I'll talk about that after we have a break. But here we're not, we're just creating an ordinary array that's fixed in size. So we're going to create one that is of 10. And we're going to take and zero out. So the instructor, believe it or not, is actually kind of trivial. Because all the other functionality at this point is pretty much given to us. Interesting thing to note, though, that instructor does not inherit from person. It inherits from employee. So make sure you are inheriting correctly, because we have now an instructor that's an employee that's also a person. If we inherited directly from person, which is a classic mistake, actually, then we don't have any employee behavior. We haven't designated them as an employee. So you do have to make sure you kind of get the lines of inheritance to follow correctly. We want an employee because we want to know what the instructor is making, stuff like that, all of the employee behavior. Here's the interesting part. Now we have another array. So let's keep track of 10 students. So I have an array set here with a student array, and it's equal to 10 integers. Because all of our IDs are integer values, and we're storing the IDs in here for each one of the students. So we have instructor with the instructor name, a default constructor, Actually, it's not really the default. It is a constructor. We create the instructor. We take super instructor name, should look familiar. Set ID, should look familiar. And now we have a little loop here. And I put the loop all in one line. You can put it, if you don't like it all in one line, you can. It's a classic for loop. I put it on one line so I can just cut and paste it. So it's kind of an easy loop to kind of do. What are we doing? In all one of the constructors, we're defaulting everything to 0. So we're taking the student array and we're assigning 0 to each one of the 10 students. So the instructor starts out with no, the ability to take 10 students, but no students assigned. And because we don't actually have a constructor, we could, that's why I say try to follow the logic of how the assignment is structured and what methods and what data they're telling you for each one, because then you can actually implement the logic correctly. You could theoretically put in a constructor and require all instructors to have students assigned to them, but how do you know if the students existed? You know, it's kind of like Maggie and Susan. You know, we're allowing Maggie to be assigned to Susan, but Susan doesn't exist. And what about Maggie? You know, what order was she created in? So we have more flexibility in the creation of these objects if we leave it out and not require it, which is why we have all these interesting constructors. So we have the instructor taking on the name. I think I just went through that. We have one that's taking on, this is interesting, it's overloading. It's going back and we're supering. When we do this, we're going back to employee. Well, we're going back to employee anyway, but now we're running the constructor that takes the salary and the name. Because inside of employee, we had one that took the name and the salary. So we're supering back to the salary and the name because we're taking that in on the constructor. Don't assign it, super it back. It's the best way of doing it, actually. People that are afraid of the word super, start using it and won't be afraid of it anymore. I see people all the time, experienced programmers that won't use the word super and won't use this. I don't know why. I think maybe because it didn't exist in C++. I don't know. It's something Java oriented. Actually it did. There's a way of doing it in C++. But those people didn't do it in C++ either. So, all right. We also know we can actually run super as a function. We can actually type in super and run it like that if we wanted to, and then take this out. But I've spelt it out for you just because it's easier to kind of see it abstractly. Here's the piece that is out here in the driver program that I showed you. And this is the class level method. Don't worry, we are actually almost done. We're going to see this work in a few minutes. And this is implemented in instructor. And in instructor, we have a static, and it's declared as static because it's accessed outside of the instances. It's a class level method. And this one's called find students, because what does an instructor, every time a new instructor is created, it needs to go out and find its students, because we're not giving it a list of students. So this is the functionality that has irritated a lot of people and has been the source of questions. And how do you find the students? It's actually not too bad. It's actually, I gave you the code already, actually. It's and how we assigned the teacher ID for the students. Well, the instructor is going to do the same thing. So the method is taking the public array, the persons array that is out of the driver program. And here I'm just setting, you don't even have to do it this way. This is a long way of doing it, actually. You could probably customize this to meet your needs. I'm just setting a temporary variable called edit teacher. I'm going to find the teacher that I want to edit. And after I find the teacher that I want to edit in the person array, then I'm going to edit that person's list of students, those 10 students. Each object out there has, each one of the instructor objects has its own individual instance array. And the instance array is keeping track of 10 students that are associated with each instance of those objects. We're modifying that instance array through a class level method that we're running from the driver program. This method is being executed out here from the driver outside of the instances of all of the objects. So it's taking as a parameter the array that is storing all of these instances. If you understand that, it's a piece of cake, because what we're doing now, and we can't run this from instructor because Well, actually, we could, but it's a static method. It's meant to be run from the main driver program, and it's working on all of the instances. So we've taken all of the people that we've created in this array, and now we're going to find the students and match them up with this instructor. And here what we're going to do is find this instructor here and put it in a temporary variable, and then take that instructor. For each one of these instructors, assign some students to that person's array. So for integer I is equal to 0, I is less than, this is why we want to have that get maximum ID. We're using it all over the place. We don't have to remember what it is, we just get it. At any one moment of time, it might be higher. It's going to be, hopefully it won't be low. Actually, we can't delete students. I didn't do that to you. There's a variation of this that has you delete things. But it's actually kind of trivial, and it's not really that bad. Okay, so for every one of the people in the person's array up to the maximum number of people that we've created, if the person is an instance of student, find the students, okay, then the edit teacher, which is the integer, the temporary variable that I'm using here to keep track of the teacher ID, treat the person array as a student, because we know they're an instance of student. So we know that they're an instance of student, so we can say student. Treat the item, treat the object as a student. This is not a typecast. This is an explicit declaration that says as a student, not as a person. Make this bigger because this you got to understand. This is the key to the whole entire problem. As a student, get the teacher ID. If you leave this out, you're going to get a message. And this is where I said this is where that casting message. You're not casting, you're not changing any data types. Don't follow that trap. Although the program code will compile just fine after you follow the error messages and typecast it and do all the stuff, the logic is completely wrong. So this is what makes it tricky. So the person that's in that array is a person. So treat it like a student by explicitly declaring it to be a student. Run the getTeacherID. GetTeacherID is part of the student class. The student, it's not part. If you run this, the error comes into place because this is not part of person. It's part of student, and so it's going to come back and say, "Hey, the method is not found. Invalid method." You know, do you want to change this into a person, or typecast it out? Or do you want to add the method to the person's class? No, it belongs in the student class. So after you have gotten that, you're getting the teacher's ID from the student object found. And now we're taking it down and saying we're sublooping. So if you don't like loops, you're not going to like the way this is done. We're going through it once. We're finding the students. We're taking and we're getting the IDs that the students have been assigned. Now we got to go take the teachers, find them by their IDs, and assign them to the students. So for integer j is equal to 0, j is less than maximum. Same thing as before. It's the same loop. Here now we're finding instances of instructor. And we're saying person get ID and is it equal to the teacher that was found? If it's equal to the teacher, and this is, keep in mind this main loop is going through each one of the people. So find the first person. Are you a student? Yes, I'm a student. What's your teacher ID? Here it is. Here's your teacher ID. It's the edit. Now copy it to edit teacher ID so we can hold on to it. Okay, go through again. Are you a teacher? Oh, you're a teacher. Okay, good. Here, you have the student because your IDs are equal, which is what this thing here is doing, saying get the ID. If it's equal, then as an instructor, treat the object as an instructor, run the add student method. Add student method is going to go through the array and add the student to the 1 of 10 that belongs to the student array that belongs to the particular instructor. And this is an instance level array run from an instance of instructor, which means we have to use this object, this person object, we treat it like an instructor and run the add student. You're going to get the same error message if you don't follow if you don't specifically ask for the instructor. Because it's going to come back and say, well, add student is not part of the person object. Yeah, no, it's part of the instructor object. All right, so you're going to see all of this come together momentarily. Let's just make sure we've followed everything in the assignment description. I know, you're all ready for break. I know. I can sense it. Don't worry about it. I'm not stopping yet. I'm not stopping until I'm done. Yeah. And I'm going to be done momentarily. Don't worry. All right. So, and then after the break, no one's going to come back. But actually, in a few minutes, you're going to go, wow, that assignment's pretty easy. And maybe some of you are going, yeah, that's just pretty easy. If you break down all the different things and you start thinking about the object, which is the purpose of the assignment, which is, why I'm using it. It's well in the science, it's been used many times, and you won't find the solution on the internet either. These are the instructors that are using it are very cautious about the solutions because everybody's using it. We're not going to let a solution get out on the internet that someone's going to cut and paste and use. Besides, it's not something that, it looks like an assignment. It's not something that someone's going to accidentally answer for somebody who posted it on a bulletin board. And yes, it was posted actually 2 weeks ago. Somebody in this class, not this class, probably the weekday class, posted the entire assignment description asking for an answer to it. It's like, all right, no. And luckily a couple of people went back and said, this looks like a learning exercise for a class. Why don't you learn it and answer it yourself? All right, so. Okay, so these are the classes we created, just to recap here. And now I just went through the entire logic of the student array, the student ID. So all of the above methods are private and only accessible through the access methods. We've seen that, we looked at that already. And a two-string method for each class to print out the available information about the current object. We did that. In the person class, two-string is declared as abstract. We saw that. And we did that abstract because we want to make sure that we implement it. And it gives you practice creating an abstract class as well. And then here's the details about the static, which means it's a class method. Find students, we looked at that. That took on the persons array. And in the instructor class, to fill in the instructor's objects student ID array and the corresponding students' teacher IDs fields. See the test program for a better understanding. In fact, the text down below kind of goes through that details. I'll let you read that on your own. Person should be declared as an abstract class, obviously. We need that because we have anytime we have an abstract method in there, we need to make the class abstract. Provide multiple constructors and methods if needed. We did that. Check the test.driver program at the bottom. That's the driver program I showed you without the comments. If the class can use a parent class method or constructor, use super. We saw that. To call it to reduce the redundant code. Make sure the test.java program can work with your class. We're going to do that momentarily. See the sample layout, program on the bottom. Hint, hint, there's no main method in any of the 4 classes. We only have one main method. It's in the driver program. And make sure that the ID is unique across the objects. Declare a static last ID in the person class. That's our maximum ID, actually. All right, so submit 1, 2, 3, 4. 1, 2, 3, 4. I don't need your driver program. I just need these class files because the driver program is the same for everybody. And the driver program is on the bottom. So then we have the sample output. The sample output you're going to see is going to be a little different because I did it for instructional purposes. And nobody's asked yet, but no, the source code is not available. Because this is really, some people have done this on their own already. So it's best if you do it on your own. You're looking at it now, you're seeing the logic. So hopefully you'll be able to implement it. But if I gave you the source code, I might as well just write the assignment for you. So I'm not doing that. In fact, I skipped some functionality. I only have the, let's not modify it. I only have the students, I only have the instructors finding the students. Students can't find any instructors. So it's a trivial change, actually. It's not in the same logic implemented again. The main program here is the same thing that you're going to get. It's going to have a lot more comments in it. I stripped it out. I made it a little easier. When I run it, I put in some extra comments in the code. So you're going to get a slightly different output than what's in the assignment example. And this is an application, not an applet, by the way. Actually, it's the next assignment. I need to work with that. I'm sorry. Run it as an application. As a note I need to make on the next one, actually. Alright, this is the output. Let me make this bigger here. There we go. In each one of my constructors, I put in a system out that's printing out the information that's going on to show you the big picture. So what's happening in here is, and this is the interesting thing to note, in the beginning we have Peter created. So student Peter's created with the teacher unknown, and his ID is 1. So he's a student. This unknown happened because I put the name to unknown, just in case, because we didn't give Peter a teacher. Now I have an instructor named Peter, and so now I have, interesting, I have an employee Peter that was created with ID 2. Now I have an instructor Peter created with ID 2. They're both Peter. They're both an instance of the second creation, but they're both the same. An instructor is an employee, also a person. In the person, I didn't do it because it was like a little too much output. You could put a system out line in there that said a person was created too. And then for each one of these, I'd see a person too. But let's just assume we're also getting a person. And the order's interesting because it went backwards. It went to employee, then it went to instructor, which tells you it goes from person, employee, instructor, so the firing is in reverse order as the object's created. It kind of cascades in the opposite direction. And the IDs are the same, so we know it's the same Peter. So here we have employee Sandy that was created with ID 3, salary, kind of trivial. Janitor Bob. Here's employee janitor Bob. Where's Bob? Bob's in here. So here's Bob. Employee Bob was created. And then we have Tom was created with teacher Peter. And interesting thing to note here, Tom and Peter, right up here, is that we have the correct Peter. It's the second Peter. The first Peter was a student. The second Peter was the instructor. This I would highly recommend. It's not going to be in the example. I put this together with those systems out. And I did this so that I could go through here and make sure I had my functionality correct. Which you'll see a lot of business, actually a lot of professional people will do this. Because how do you know that it used the right Peter? How do you know that the objects are being created correctly? Until you actually kind of, when it happens, there's no output. You'll see the output at the bottom, but you're not going to see it at this level. Maggie was created with teacher Susan, and ID is 0, because Susan doesn't exist. Maggie was created, but Susan hasn't been. Now we got Susan. So now we have Susan. Well, Susan was assigned to ID 7. She was the last person, actually. Susan's up here. Susan was the last person who was created. Oops, here's Susan up here. And so then we fill in now. After the fact, we're going to run instructor.find students, and that's where it gets student added. Who did we get added? Well, we only had two students that were associated anyway. So now we have this one is showing how Susan was added to Maggie's, and this comment that says student added comes back to the instructor. And what I did, which I didn't show you yet, which is interesting to note, in here we have a method called add student that's being run from our find students method, our class. So inside of the class method, we're running an instance method called add student. Add student is on the bottom here. This is where that student added is coming from. It's going to go through the student array that belongs to this particular instance of this object, because it's an instance level variable. It's going to go through and it's going to add. It's going to change it to the ID that's being passed to it. And the ID that's being passed to it is coming from find students up here. So we're going to get the ID of the teacher that we found that says it belongs to this student who says this teacher is their teacher. And we're adding this student to the teacher's array of this particular instructor. And that was a mouthful. All right, so and then what do we have down here? We have a student added. And then this is actually what you're going to see. That's the toString function, because at the bottom of the driver program, we have this little loop here that's exercising our toString method that is from each one of our objects. Each one of our objects is a person in here, but they all have 2 strings. And when we run the 2 strings, it's doing nothing more than. In fact, what your toString contains doesn't really matter. Here they're not all consistent. I just have, Peter's a student, Peter's an employee. Sandy's of this, Tom's of this, Maggie's of this, Susan's of that. So. And that is the output that was created from the code that I just showed you, which is your assignment, actually. Each one of you needs to implement it on your own, though. And I'm not going to give you the source code. And as you notice, there's a little functionality missing. We don't have an ability for students to find teachers to associate with. And if you think about it, unless a student, the way this logic's running right now, unless a student has a teacher ID, they're not going to be assigned to the teacher. So we only ended up with two students who had teacher IDs. And they were because they were assigned, using the constructor, they were assigned teachers. So we have a bunch of students out there that might not actually be assigned to teachers. So you could build a logic in there to say, how do we assign that? How do we get teachers assigned, students assigned to teachers? So it works both ways. And plus, that is also just one way of putting it together. And as you can see, it demonstrates almost everything. Which I like the assignment because it is definitely if you've seen it, it's very comprehensive. I mean, it's covering every aspect of object orientation. All right, now as promised, we'll take a break. I am looking at my clock and it looks like it's 11:35. Do we want to count this as a lunch break? Maybe make it 20 minutes, come back at noon or something? Or how long do you guys want?
20 minute lunch break?
Yeah?
Should be longer.
Should be longer, I think. But are any of you going to come back? That's the question. I know you guys will. Good question.